Everyone, welcome. How we doing? How's it going? Right, let's just make it chat only on my phone. There we go. Cool. Right, so let's get the terminal open. So, radio. So last stream, we did some more UI. Welcome UI. We got textures working, and we got. It might be a little bit small now because I've upgraded my display. But yeah, so we got textures working, and we got a little glyph rendering as well. Hey there, Akras. Welcome. Oh, and we've got the rounded corners on the box. That was a good one. With anti-aliasing as well. And then after we got those done, we were kind of preparing for doing like an optimized shader. So we got some profile information back from the GPU, and we display that in the terminal now. So this is probably going to look a little bit small. How is the window size for everyone? Because I've changed my display now. So I've got a new monitor, and it's 4K. So I'm wondering whether I think I should make the screen bigger, because I can't literally just make it bigger. I have to change some numbers. How's the size of this window for everybody? So I might have to make it a bit bigger. But yeah. So in this stream, I want to finish off a little bit of so here's our little shader we've got. So per pixel it just runs this shader, goes over every draw command right now, but we'll fix that in the future. And it checks to see if this like shape that we're drawing is at where this pixel is, and if it is, it'll pick the color and try and render it, and do all the alpha blending stuff as well. So yeah, I wanted to start off and fix this really. Like right now we don't have sampler support in the GPU library, so we need to add samplers in. I think we can just start with that and just whack that in basically. Well, it's okay. There's not much detail to show, right? Yeah, it kinda, but it's like it's proper teeny. But yeah, I think it's 800 by 600, and I've got that just magic numbers just in the code base in places. Is 4K a huge leap from QHD? So QHD meaning basically like, yeah, I know what you mean. It's 1440p. I don't know, because I owned a 1080p screen. So basically I've gone to a 32-inch screen, and the one I used to use, this one here, I used to use a 22-incher, proper tiny, and my eyesight's getting a bit worse, and if I went bigger I would have wanted a good resolution, so I went with the 4K. And it's got its issues on Linux. Things are not like, some things show up proper tiny, and you have to sort of like this task, like see these things down here, they're all proper tiny. Well, I wonder how that shows up on the OBS. Yeah, that's gonna be an issue now, because we moved that to cover up the thing, but it's now it's covering up my Vim. Wait, or is it? That's a good question. Yeah, so I went to the 32. Yeah, we'll move that bit down. Otherwise, you guys won't be able to see the file I'm in. But yeah, I went for a 32-inch one, and luckily, because it's that big, even if something is shown super small on a 4K screen, it ends up being readable to sort of like, still viewable as tiny. Because I've got 1440p on like a laptop, and when stuff is tiny on that, it is impossible to read, which is not good. This one in it. Alright, let's budge this one down. Hmm. You know, let's be unprofessional. Let's make it go off the screen. There we go. Yeah, I got a baby. He's being changed. Little baby. 10, 1024 by 768 should be enough. Yeah, and that's like the smallest screen, isn't it? Yeah, I could just do 720p basically. Yeah, I think that'll be a good idea actually. Just make it bigger. So why don't we start with that actually? Let's just because we've got magic numbers everywhere for that. Let's converge the magic numbers. Like obviously I could make it resizable, but that would probably be even more effort, right? So let's search for 800. Yeah, so these are kind of where all the places they are. Obviously there's some other 800s in the third party, but in the source ones is what I mean. These guys. So let's just chuck it in like game.h. Then everyone else should be able to get it, I think. So we're just chucking here. So I think we'll do 19, we'll just do 720p. That'd be easier. Plus it'd be better for people who are also downloading and running the code on their screens, right, as well. Should be fine. Yeah, thank you. Appreciate the yeah. The baby's super cool. Like he's just proper cute. And I've just had like 5 weeks off work. It's my last week now. So I'm starting next week. So just been chilling, looking after the baby. Yeah, it's super cool. Is it better for you, Ko-Fi or sub? So Ko-Fi is much better. Yeah, because Twitch takes like over 50%, I think, now. So that's why we have the Ko-Fi, because it's just better. But people like the integration with Twitch, so up to you really. But yeah, I would appreciate it. If it's, I prefer over Ko-Fi myself. Mine is going to school tomorrow, miss those days. Yeah, it's so funny how they're like, they just cannot do much. They just sit there, pretty chill, or they start crying because they need either eating or changing. It's crazy how little they can do. Right, there's an 800 in here. There it is. So this is really bad. Magic numbers, people. They will bite you. But also, magic numbers are more readable, right? So they've got pros and cons. Right, so in gfx.c, there's a whole bunch of the magic numbers. I don't know why I don't do that one more often. Way easier. Right. 800. Okay, gotcha. Kill anyone? All the magic numbers. Let's get the height 600. Right. We're looking good. And one more in the shader, isn't it? Oh no, it's just in the... Okay. In the OS backends. When we create the window. Clever. Right, one more in the Windows one. Oh yeah. Right, so that should hopefully. Yep, there we go. So we run that. We should have a bigger window now. And it won't be as... yeah, so it's not centered anymore. Yeah, I know it's like, maybe we should do a bit bigger. Wait, we did 800 by 600, so we just made it like wider, didn't we? We could do 960 by 960, keep it square. And then we did that. No, you want it like 4 by 3 kind of, don't you? Hey there, Nico, how you doing? Oh, thank you there, Hocus Pocus, for the support. Appreciate it. Um, we've got a... Switch to your Bunty because you know family and stuff. No. Yeah, Arch is fine, man. The bleeding edge is fine, not to worry. No, I actually use Manjaro, so it's a bit more stable. I guess shaders work in normalized chords, independent resolution. Yeah, they're independent, which is great. Although we've hard coded a few things, like the inputs and 760 might be a bit bigger, right? But that's not 4 by 3, is it? That's just 16 by 9. Is that 50 extra pixels? Would that be, is that enough? No, it's smaller, it's even smaller. So is that even a standard resolution? Like what's it's 4 by 3 resolution. Because you've got like mine's going completely blank now. What do we used to have it at? So it was like 800 by 600. Yeah, it's pretty, yeah. There's a... I don't know. Yeah, I don't want to put it too high though. Because if I did 1080p, then someone on a 1080p screen would just be like... Yeah, maybe that's good enough. This one here we got. I don't know how... Yeah, that's better. We'll just roll with that one. So 1280 by 960. And we'll just change the graphics, make it bigger. So it will fit on someone's 1080p screen. Yeah, do some SDF in a bit. But 2D SDFs. Rightio. So let's fix up these guys. These draw commands are hard coded, right? So we kind of just put them in the middle. Let's just do this nice and easy. 640 by, is it, wait a minute, what was it? It was 960, wasn't it? Yes, it's 480. 640, 480, okay, good. So, Excellent. So these sizes that we've done, I only did like 100 here. Well, so we've kind of like doubled it, right? So we went from like, well, did we double it? Well, let's just double it, right? So let's say 200. We've already got 200 in there anyway. So let's quickly close 200s. So let's make that 400. We'll make these 40s, 80s, for instance. And then we'll make this 100. See, I could have just doubled that number we had. 800 by 600. No, it would have been a bit too big. 1080p. Screens, right, let's try that one out. There we go, we're back in business with a bigger version. No, we're not doing SDF text. Multi-channel SDF, that's just a solution for handling SDF text, some more. Yeah, we're not doing that. We're using more like this. So the idea with this, we kind of have a bit of a problem right now. Well, it's not really a problem. It's just the way we've done it is a little bit silly. So currently, we have this sort of draw command type, right? It's just ABB, AB rounded, circle, texture, glyph. Now I've kind of just chucked in like a bunch of other parameters in here, which are sort of like used in some, but not used in all of them. And really should kind of be like unioned as well. But really where we're kind of getting at is there could either be a color that's supplied or there could be a texture. And there's also like basically like a shape. So there's like a shape and color. So what I'm thinking about doing, and we will be starting this today, is we're going to separate the concept of shape and color from this. And we're just going to have a way of basically, like I've already done this in a previous sort of application I tried to make. And basically what we used to do is you used to be able to get like a canvas, like anytime you want to draw something. Wait a minute, let it do its thing. Right. Anytime you want to draw something, what you used to do is like you would place down like some sort of like you would place down some SDF shapes and you can like union them together. Say this is like two circles, and that you can make a shape like that, or maybe you can have it subtracted, like a circle subtracted from a shape. Yeah, if I can even draw it, right? That's horrendous. Right, imagine that's like two circles like union together. Yeah. And then you could then choose afterwards, how do you want to color this? Does it come from a texture that you then texture over it? And only in the places where the SDF is on the inside, obviously. Or do you just color the thing? And does it have a border? Because you can do a whole border with SDFs as well, quite easily. So I'm thinking about basically just giving you a bunch of like basic shapes, like circles, box, and that sort of stuff. And you'll be able to comprise a shape out of those shapes when we do these draw commands, I think. Color and mask, geometry, and SDFs can be treated as a mask. Yeah, it's kind of, yeah, that's another way of saying it. So you're essentially building like a mask of stuff to discard or keep. And also like how you want to color it. Because you can you can color it based on the distance as well, like, and do a border, sort of thing. So yeah, it's pretty cool. Okay, so I want to start by getting the sampler working. So we need to add a sampler, because currently it's hard coded, like our texture's hard coded to a single texture at a specific width. We want to make it so we can use any width. So we need to add sampler support into the game. So let's go to the GPU side of things. So for a sampler, it's another type of resource. You got buffer, texture, and we'll do sampler as well. Now, it could be a separate thing, but it's going to be accessible via a resource ID anyway. Now it's got to figure out these enums. So we might not need a lot of what the sampler offers. So we might sampler. Oh wait, I'm in the wrong header. Vulkan core. Right, here we go. So there's a lot of stuff in here. So we could do one of these big structures. Yeah, we could just copy this whole thing basically, and then do our own version, because it's got a map to other APIs. And it does map to basically all the other APIs except for this field here at the bottom, unnormalized coordinates. Yep. Yeah, it's just one of them. One of them. So, but what we might do for now is we might do a simple version, because we probably won't need a lot of this stuff anyway. So you want basically a min and mag filter, right? But you might just call it. So we might just have filter, just keep min and mag filter the same, just to keep it simple. Because I don't think we'll need a lot of the other ones anyway. Map mode can probably just be the same based on filter basically. And then the address mode would be its own one as well. So we'll do two enums, and we probably could just leave it at that. Yeah, I think we're gonna leave it at that. So we basically want to have this as an enum in our code base, and we want to have this one as an enum as well. We just gotta change it for ours, you see. So you want like a sampler, GPU sampler filter. What are we doing exactly? So we want to have like probably a U8. Sampler filter, get rid of those two. Get rid of those horrible spaces. Let's try that one again, shall we? This is sampler address mode. Sampler, oh, already got it. Address mode, fantastic. Okay, so we probably need it up to about here-ish, I guess. Nice. So we make a new sampler. We want to probably just have filter and then address mode, I think. Whoa. Egotist, thank you so much. And Fabulous Flow. Appreciate it. Sorry I missed you there, Fabulous Flow. I kind of got distracted. Appreciate it, guys. For 6 months as well. Thank you. I love how the thing that read it out said less than 3 for your message. That's great. Does your window resize smoothly? So we don't really have window resizing right now. But I know what you mean. I've never been able to get good window resize working on Linux, but I see applications like the web browser, and they can do it. So, well, they used to at least back when. But there's All right, let me try something else. You see that? Doesn't mess up, does it? When you resize in that corner. So it's like, how do they do it? Because it always gets jerky for me when I do it on a game. So I wonder how it can be done in a good way. But yeah, we haven't got window resizing yet. We're just working on like everything else. We spent a good enough time on the engine at the moment. Right, so to make a sampler, I think it's going to be the same as this resource. Rightio. So we're going to allocate a new resource. We're going to give it the type of sampler, and then give it the debug name. And then we're just going to say sampler, filter, and then sampler, address mode. Oh yeah. So we need to obviously go and make that thing. So let's go ahead and do that. So here's our resource structure. It's just a union of stuff. So we just need to add it in for the adding these two fields. Now, all we have to do from here is basically create it in the backend now. So we're gonna have to add a new one of these guys, backend create sampler, and it will create us a sampler which we can then just use in our shaders. It's that easy. Quick and easy. Did I spell sampler right? What's going on with me? Didn't even write it in. Cool. So yeah, now what we've got to do, cool, is actually implement this in the Vulkan backend. So we find this one in the Vulkan backend. Well, we're meant to find them, but we don't. So I've got to go ahead and do a Vulkan.c. Thank you. Find that one. Go to the bottom. Bam. So got to do a couple of lookup tables, and then we're good. Hey there, Lots of Red. How you doing? Welcome. What does your engine actually do? Have red in some places. From what I understand, it computes. The written code on. I'm not sure what you mean by computer written code onto the screen. So basically, what my engine is capable of right now, here it is. So we've also got full controller support on Windows and Linux. So this runs on Windows and Linux. We use Vulkan for the graphics API. We've got a little abstraction on top of it, and that is compute only. So we only use compute shaders. We don't use any of the traditional rasterization API. We're planning on doing full 3D game using nothing but this GPU API, which is basically it's about 250 lines of header code, like header file code, and the implementation is a few thousand, about 3,000 lines. The GPU stuff. But yes, the plan is from here we're going to do some UI. Going to get a nice debug UI thing, so we can get some nice overlay up when we're doing some prototyping. We're doing controller support from the get-go because, you know, I want to take my hands off the keyboard and control with a gamepad because it's cozy. It's something different. And then, yeah, we do some prototyping for a new 3D art style. I've got some ideas. This is not entirely unique, but it's more untraditional, the sort of route we're going, basically. Trying to find my own sort of thing, you know. Yeah, that is the plan. That's what the engine does. That's the plan. I've been told that you need to rebuild the swap chain on another thread, but I'm not entirely sure how to make it work. I'm not sure if that's... Is that really what you have to do? I don't think it would be a problem on the main thread. Because if the swap chain takes too long to create anyway, then doing another thread isn't going to help. Pretty sure. But yeah, if your maybe if your whole renderer has to be on another thread, maybe that helps. But then maybe that's how you fix it. You put the renderer on another thread, then the main thread. Maybe, I don't know. I don't know if that fixes the problem. Yeah, I'm not doing good, man. Sorry, I'm not doing bad. I'm doing good. Just been chilling. Got my new monitor, so I'm now on a 4K monitor, which is pretty cool. I just gotta get used to it because it's bloody big. But it's cool because I can now see the text and I'm not leaning forward every time. Trying to make out some things on the screen, which is good. This should be a lot better for the posture and everything. Oh, that T is just about right. What does compute only get you? It gets you a simpler API, so it's more simple. Like if you've tried to do Vulkan, it's very complicated. I just want to see what happens if we can do it, if we can achieve compute only, and how much easier or how much harder was it than if we used standard vertex shaders, fragment shaders, and all that stuff, meshes, basically. Can we avoid all of that stuff? You know. Create sampler. You get a resource backend. Chuck that in there. Now you need a VK sampler. How do you find your new monitor? Is it good? Yeah, it's pretty decent. Like, I plugged it into my PlayStation, and it looked really good. On Linux, there's a few little things about it where things are kind of small, but because I've got the 32-inch monitor, the small things are still readable. But yeah, I'm just getting used to everything, basically. What's another really great thing about it is it's very high refresh rate. So everything's like proper smooth. So I'm sure like when we do get doing some like graphics program, like more 3D graphics programming, it's going to really shine in those areas. Yeah, it's much better because my other one was 22 inches and 1080p. Like this is like far more high quality. You can just see a lot more with it, which is good. Like I had a 32-inch 1080p screen before, and you could see the pixels. It was so bad, like this close where I'm at. But now I got this screen and it's 4K, so it's good. Yeah, using Clang D. I think we use the NeoVim LSP, but yeah, that sort of stuff. So we should be able to say sampler. Yes, that's good. So just got to do a create information for that now. So in Vulkan, obviously it's VK sampler create info. Create informations. So with these guys, they have obviously a whole slew of fields. So S type. So this would be VK structure type, sampler create information, bam. P next, null. That's for extensions, flags, 0, I think. Now let's get the rest because they're all non-standard. So the idea is what we want. Oh man, I had that all going so well just for a second. I thought that would do the whole of it. Oh, let down. Right, so we've got to transform that filter input that we got and the address mode to some local variable. We'll do that. So we're like vk filter equals resource sampler, because that's where we stored it, filter, and we're going to do some form of like lookup table, but we'll get to that in just 1 second. Sampler address mode, so we'll convert that in just a second. So in goes here goes filter, then we need to probably get mipmap mode. Figure that one out as well. This is address mode, all the same. You can do individuals, but we probably will never need that feature. Load bias 0, false. Let's say VK false, but yeah, false should be fine all the time. Right, so is there a none? Never. Good. Min lod, max lod. Ooh. Hmm. Let me read into that for a second. I'm not sure we got VK create sampler. How? Okay, we've already answered that one. Ooh. Right. So min map. How does this read? Used to clamp the computed LOD value. Right. So it's obviously going to do sample. To avoid clamping the max, use this one. Good. So we don't have any mipmaps yet, but we will. Right, 1000. Okay. Border color. Border black. This one is it's not portable. This unnormalized coordinates, so some platforms don't support that. And we pass that in and sort that out. We need to declare a VK result at the top because our macro sort of expects one to be there. Right. So that should be a sampler created. Now we need to do some translations here, do some lookup tables between our enum and the Vulkan enums. And then that should be Yeah. Right, so that should be the sample mostly done then. I just have to create our samplers after we get these in. Cool. So let's go and grab these here. So I'll make a lookup table. So it's just going to literally be like, wait, what have we done but in the past? So we've got these things to help convert like our vector 3s to like these guys, right? The little functions, but surely there's some lookup tables somewhere. No? Oh, the formats. Voila, there you go. Hello, Dr. Merrick. In a infinite generous on y, vector.size returns 1 when it's clearly 3. Oh, it is. Does it really? So you got like VD, vertex data, so it should copy it, right? Because that'd be a reference, right? And that's default constructed. Yeah, I don't know why that would be. Can you try and do a reproducible one in Godbolt maybe? If you go to Godbolt, can you do like a reproducible? Obviously, don't use a vector 3. Yeah, obviously don't use a vector 3 from foreign library, and just make one temporarily and just see what happens. See if you can reproduce it using using Clang or something. Suspect it's packing. I'm not sure what you mean by packing because you're clearly pushing it 3 times. Isn't it working fine? You got 12, right? Now size of vertex. Oh wait, size of vertex data. No, vertex data is. Oh, it is 12, isn't it? Is it something to do with the operator precedence? Yeah, but is it because of your operator precedence? Can you remove the size of and try it again? Because the shift left operator, I don't know what the precedence is like with the multiplier. You know, I think it might be doing something a bit iffy here. Hmm. Yeah, sounds weird. Very weird. Have lower priority. Yeah, I don't know. It should be fine, right? I don't know. I didn't prefix this bug with GPU, did I? And also finish it with account. Criminal. And then without size of, do you get a 1? You still get a 1. Mom, what the is going on? Can you try and access the element? Like, is vector bounds checked? It works, does it? Just strange. Right. Huh. And it's like you're writing to it there. Yeah. Yeah, maybe it could be an optimization thing, but I wouldn't think so. Yeah, it could be doing some weird optimization though. Yeah, maybe try turning optimizations off and see what happens. But I don't know. That'd be a weird optimization. Sampler filter count. Right, and then so you want the filters, you also want the address mode in them. Oh, hey there, Ansel, how you doing? Cool. So we'll fill in these guys. Sampler address mode. Oh yeah. So there's also the mipmap levels, right? Some silly stuff like that. Mipmap mode. We'll get one of them in. It's basically like filter, but for mipmaps. Oh yeah. I'm gonna chuck a filter in there and get that out. Nice. Bam. So, what is our plan? So, the plan is we want to have GPU sampler filter. Nearest is first, isn't it? Right, nearest. That will send out VK filter nearest. There we go. And then linear. Oh yeah. Then the mipmap mode. Mipmap nearest. Then linear. And the address mode has got a few. So we've got about 5 of those, yeah? And then those are going to be VK sampler address mode. Repeat. Mirrored. Repeat. Clamped edge. Clamped to border. Mirrored repeat, clamped to edge. I don't know how cross-platform that one is, but I doubt we'll ever use it. So I could just remove it, but anyway, we'll keep it in there anyway. We'll see. We'll see how it goes. So, right. So now we've got our lookup tables. We can now finish off the sampler create function. Pretty easy. We just use these super lovely lookup tables. So it'd be GPU VK filters lookup into there, bam. GPU VK map modes, look up into there, bam, using filter, good. GPU VK address modes. Now we kinda got those names wrong. Just a little bit. And voila. There we go. The sampler should now be created, and I'm sure to use it. So now let's actually just go to the GFX side of things now. So I want to go to so when we start up, I wanted to create just a few samplers that we're going to be using. So GPU resource ID. So we're going to have a clamp point sampler, clamp linear. Well, we call it nearest probably instead. Yeah, clamp nearest, clamp linear. Sampler. So we'll just create these two for now. If we need any more, we'll just add them in as when we need them. So literally, when we initialize the GFX side of things, we just make these two guys. So equals GPU sampler initialize clamp nearest sampler, GPU filter nearest GPU sampler clamp to edge. Boom. Then we've got linear. There we go. So there's our samplers. And I think I need another tea. That was a good tea. Should get one of them. Right, so what we're going to be doing now is trying to feed that into the shader. So we have a UI draw command, right? We're going to be making this better. Let's just chuck a sampler on here. So read-only sampler, right? Just chuck it in there, get it to work. Sampler, right? Cool. So where do we set a texture? Right here. This one. So we'll say sampler equal GPU resource ID clamp linear sampler, right? So when you draw those glyphs, they probably want to be point sampled. Nearest. So we might also in our UI renderer, we'll have one passing the bundle constants that go up here. Ooh. Clamp nearest sampler. So I have that pass right in there as well. Bam. So yeah, now we're just going to create the shader code where we actually use these things. So when we use the texture now, rather than using load texture, we can now uncomment this guy, which we did originally. sample MIP level. So we're just sampling from a texture at MIP level 0, because you have to be explicit about the MIP levels in compute shaders, because you don't have DDX and DDY being calculated for you, right? So you have to explicitly provide the DDX, DDY, or the MIP level. So this sampler here will just be command.sampler. And then for glyph, what I'm hoping about doing here is using BC, which is the bundle constants passed into the shader, and we're going to be using the clamp nearest sampler. Right, so hit compile on that. What we'll find out is that there's no generic for it for some reason. Let's look into that. Oh, it's got to be a sample texture, of course. Right, no biggie, I'll just change that around. So what we didn't do is we didn't. This needs to be a sample texture because they're different. Read only and read write are kind of like a storage texture. So you can only load and store from them, you can't sample. Sample texture you can load or sample from. Shoot. Awesome, so that should work. It still works apparently. Pretty good, although it's doubled the cost of the shader. It literally, oh wait. No, we've doubled the size of the screen. Should we see how much that changed? This is about 15, well, 0.15 ms. So should we look about, so if we were to bring back this one, gotta be careful here. Source, UI shared. Right. Ugh. Oh no, it's about the same speed. That's good. Okay, so we just increased the size in pixels and it was like gonna obviously be a lot worse for that. Alright, so there's the sampler's back and it works. Sweet. Okay, so now I think what we want to do, so we spent a good amount of time making the, so we've kind of done like the bottom up approach right now when we're doing this UI rendering. We've just been like, let's just do UI rendering using compute. So we've been doing that now, and it kind of like, we've done a little green box and a rounded box here. We've got some like alpha transparency. We're rendering some textures. We're rendering like this glyph here. It's a very basic like 10 by 10 pixel glyph that's being scaled, but that's fine. I've got this nice anti-aliased ball as well. Little circle that's been rendered. So it's been good that we're doing this sort of bottom up approach. But what we kind of need to do now is like I want to separate two concepts that are being glued to one right now, and that is the what we call as a concept of a shape and color happening in a single draw command, as we're calling it, right? Nice overloaded terminology there. But anyway, so we have an array of draw commands that are sorted front to back, and every pixel currently in the compute shader goes over that whole list of draw commands. Obviously, we can optimize this. We're going to do that later. But I want to have more of the finished API before we bother doing that, right? But again, we have these metrics here. So we'll be able to see if our performance is actually, or our optimization is actually helping out in the future. So what I want to do next is, so I could go at the low level and like break everything, but I want to go up at the high level because I want to be able to define. It was due to a union. A union. What? Does sometimes speedruns have a button? Nah. We're still in the rendering code. But yeah, I want to tackle the problem for a different end. So we're going from the actual, because it's very difficult to monkey around right now. Like, we have to edit these things, and I want to add loads of them. I've got to copy paste and edit a whole ton of things, where instead it could just be a nice simple API. And so so we're going to start by getting this array built for us, and furthermore we're going to extend this and make this even better. So we've got this concept of like, how is the color achieved for this shape and the shape all in one thing. So instead what we're going to be having is separating those two things out into shape. So you basically like, you're going to say like, hey, I want to draw something now. And every time you put down a shape, it sort of implicitly was going to make a canvas around it, depending on how big the size is. So you can say, right, I want to union another shape with it. And then it'll obviously have a canvas like this size. A bit like what we're doing now with this Milton program in a way, where it sort of grows as you draw in a way. So these two will be joined together and they all get the same color at the end, right? Maybe it gets textured. And then the UVs will just be mapped directly onto that thing there like that. So it's very powerful. You can imagine doing lots of creative things for a game. And this is why I want to have effectively a very flexible system for drawing like some UI made out of basic shapes like circles, boxes, being able to do sign distance field operations. So sign distance fields, you can make some crazy shape out of them, right? Maybe just by joining two spheres together, right? And then you could say, hey, or maybe that's not a good idea, but you know, maybe a sphere and a box for some reasons. You got this, right? You can then say, hey, you can basically make this thing more rounded if you wanted. You can like, you could apply like an operation to it and explicitly make it grow a little bit and make it more rounded by something like that, right? You can also like basically like make a border go all the way around this with the color if you wanted to, quite easily. There's loads of things. You can come along and be like, oh, character's taking a bite out of this thing and it just subtracts from this shape here. So instead of being like that, you can say, oh, it's had a little bite taken out of it, right? So there's a whole load of fun you can do with SDFs, and to have that as part of like the user interface would just be really, really powerful. Obviously, it's not the most performant thing doing this, but again, we're going to try and just get all these features in, speed it up nicely, and or as good as we can. And then if it's good enough, it's good enough for the game. That's fine. And then if in the future we don't end up using these features, we just get rid of it and take it out. But I feel like it would be very powerful, especially once to prototype stuff, right, and get a feel for things. So that'd be cool. So let's make a super flexible UI thing, UI renderer, based off the stuff we've already done and make it just like super, super awesome. It was due to a union. Ooh, let's take a look at that. Problemo. Oh boy. What do you mean it's due to a union? Right, so it has this. Yeah, for the aliasing, basically. Yeah, yeah. Whereas because of this, it's got the swizzles in it. It can't be due to the union, can it? No, vector.size is still wrong on your thing. I would suggest, Dr. Murray, can you replicate it? Can you replicate the same thing in Godbolt? Because Godbolt will be a whole separate instance, right? And try and replicate just using standard vector and get your compiler on here. And use the exact compiler you're using, because you can use them in Wine, right? On here. And see if you can replicate it. And if you can't, then it might be something to do with GLM. But I think it's to do with optimizations. But yeah, try and turn on optimizations, off optimizations, and see if that will do it. But yeah. Or just switch to C and make your own vector or array, you know. Yeah. Works on my machine. Ooh, I like that phrase. Right, so before we make a start on this, I want to go grab another cup of tea because that was lovely. So I'm just going to run downstairs and switch on that kettle. And then we'll be starting in the UI.h, this empty file. Look at that. Let's go. Right. So the kettle's boiling now. Pragma once. Rightio, so we just want to make a really nice, simple API to do some drawing. So let's just go ahead, find one of my super lovely headers. We'll call it the drawing API, I think. You know what I mean? Because we've got rendering already being used. So let's call it draw, because draw is shorter. And that way we can just say UI draw, blah. Nice. So, SDF Shapes, how's this going to help us? So, the idea is, maybe it's for setup. I'll create a new project and see if I can do them on Godbolt. That's a good idea. Yeah, but will padding really change it? Dot size. It's a dot size operation. It's like the number of elements in an array. Yeah, I guess that's another thing there, Bilzik or Blizik. Rather than saying the capacity. maybe try and check the dot capacity and see what that returns, right? Say try to do vector dot capacity and see if that is something sensible. If alignment is 16, it might change. Oh. Yeah, but isn't... Yeah, maybe that's a route to take actually, what Akras is saying. Just, can you specify the alignment? And would it really be buggered up if it's the alignment though? Like, how is the size for... It's be strange if they do that, but it's possible, right? This is C++ standard library. Prints out 3 and 4. Yeah, that seems sensible. Is that from Godbolt? Oh, on Godbolt, yeah. Yeah. Huh? Because then it's like a method call, right? Surely it's fine. Hmm. Right, I just had the kettle finish up, so I'm just going to pull that thing, and then we'll start on this lovely drawing API. Oh yeah. Got the tea. The cup has landed. So, what we want to be able to do is like, so there's this sort of like implicit canvas that will get built up, maybe. But you know, if you just draw like a circle, right? You want to like put it down on the display. So you'll probably say F32 times 2, center position. And then you want to also specify some form of radius. Now you're not specifying a color yet, maybe. Because the color comes at the end. So I think what I want to be able to say is you say draw start. And this will probably just be a void thing, right? So obviously you can't start one while one is being started already. And then you say a finish, right? So basically you're going to be able to like put some shapes in. Now, the problem is you can't simply just keep putting shapes in because the shapes have to join in some way. So there is going to be some operations as well. So it'd be like a union, which allows you to like obviously say, you know, you put two circles down, union, so they get joined together. So you could actually union more than one, because you just take a min of all of them, right? That's how you do it in SDF land. Just a bit of a visualizer for it. What am I doing? SDF. So there's some 3D ones here, but we're doing 2D, right? But the same still applies. So here's like a union, right? So you take in like two shapes and you join them together. So you basically take the distance, so you get D1, D2, and you just min it. So if you could theoretically, you could union with like multiple shapes here, or there could be, so you might say like union So union start, union end. Then you probably want to have like a subtraction as well. So you subtract one shape from another shape. You can't really have more than one there. Intersection, you could have more than one there. So what an intersection, so obviously subtraction means you get two shapes, one gets subtracted from the other and it leaves, you know, so in 2D, you can subtract, this is a box and we've subtracted a circle out of the box. So we can do that one. And then intersection is kind of like I've got two shapes. What's the point where they overlap? Just draw that bit. So if you have like a circle and a box, it will just draw this bit here. So that one you could also do you could do more than one on quite easily. Which means I'm just trying to think that in the shader, like we're going to probably have like a stack of distances that it just pops off the end and mins them or maxes them. So yeah, I think we could just keep them to binary operations for now. I think we'll just keep them as binary ops, because you could just do multiple binary ops and it does it. But yeah, well, it would be cheaper. Well, wait, would it be cheaper? Yeah, it'd be cheaper because it's less data for it to go and fetch, and it might just mean you have to do a for loop though in the shader instead. So I don't know how that compares. Yeah, the way you could encode it is different. So maybe you say like U32. How many of them do you want? Right. So we're essentially going to have these sort of like binary ops, and then you have like the shapes, and then after that you have the shapes. So when you say draw start and draw finish, if you just say draw start and you don't use any of these, you can just put one shape in. But as soon as you use one of these, it then obviously expects two shapes. And then if you use another one, it so on and so forth, it just keeps going. So we'll have to write that in, which is not too hard. Then you say something like ABB, axis line bounding box, half size. So I don't think we're going to be doing a rounded box, and the reason is because there's another operation you can do. So I might call it like op, union, op, subtract, op this, op that, because it makes it, we can distinguish it. So this would be like op. So this is like a unary one where you can basically just say like, so you can make stuff like rounded. You just basically subtract the distance. You can also get things to repeat as well. It's pretty smart. Yeah. So elongate is useful to make, because only in 3D, what is that about? That's just 3, so it gives me 3. Interesting. Oh no, Ransel, I hope your phone's alright. Is your screen still good? So, Dr. Maruk, have you tried replacing GLM Vec 3 with just one float or three floats? Yeah, replace it with just three floats and see what you get, and see if the problem still persists. Because someone else must have had this problem, right? That you're having. Because you're using just GLM. So with elongate, what is it doing? Useful way to construct new shapes. It splits the primitives into 2, 4, or 8. Oh wow. Moves the pieces apart and connects them. It's a perfect distance preservation technique. Yeah, There's a play we could play with it here. I'm not sure. Is this going to be useful for UI, like for 2D? We've done like an elongate. Have we got anything going on here? So ellipsoid. So you can comment it out, right, and just give it a run. Just that one at the back. That's just positioning. Oh, ellipsoid, elongated ellipsoid. It's this one here. Right, so comment that one out. Ah, right. Okay, I see now. So it's the same configuration. Right, so stretching it across the X or the, whatever, the Z and X direction. Right, so it's elongating it. Okay, it's interesting. Okay, so that's obviously more useful for like 3D. So we're not going to be bothering with that. But that was interesting to see at least. So yeah, this one, you can round shapes, right? So you got this like triangle here. You can basically, you make it bigger while rounding it, because if you take an SDF, when you make something, when you make a distance bigger from a point, it's inherently like a circle or a sphere, depending on the number of dimensions. So yeah, you just basically do take away, right? So you can get it to round as they call it here. But you kind of, so if we were to call this round, and you do this op round, the problem is any shape inside, it's like the distance has to be made that much smaller, because you make, it's as if like you have to take the distance away from the size of the shape that gets made. Because when you say round, you're basically you're growing it. So maybe we call it something else other than round. You're sort of like yeah, you're making it bigger, basically. We'll see. We've got to think of another, like if we're not taking the if we're not taking the size away from everything else, then we have to sort of call this thing a different name other than round, I think. Because it just doesn't imply the fact that it is making it grow. But yeah. So that's an interesting op. So there's onion as well. Yeah, it's just like this. You can see the shape basically. Yeah, so maybe you could border it using this onion operation. Um, yeah, so like you're taking away. Hmm. Let's have a play around with this one. Because I'm not sure I'm going to call it onion or not, but maybe. So this one here got onioned. How did it... It's kind of repeated multiple times actually, so maybe it's a very high number. Triple onion. Oh, so... Oh, interesting. So they've applied it multiple times. That's pretty cool, isn't it? Pretty nice. And push back 6. Yeah, correct fast. Damn it. Yeah, using the wisdom of Inigo Quilles, yeah. I always struggle to pronounce that guy's name. He's a cool dude though. He's got um he's got some incredible little snippets of gold, you know, on his website. So yeah, I'm just analyzing like what this onion thing does, but that's pretty sweet. So I think I used this in the past to do borders, the UI basically. But yeah, I didn't realize you can apply it multiple times and get a border on your border. But yeah, that's interesting. Um, yeah, so I guess we'll just have another op to say. So the issue is, so we could call it onion. Um, but yeah, you're essentially giving it a border. Um, well, sorry, no, you're cutting out the middle basically and keeping the edge only. So, um, we could call it outline. So you outline the shape that you make. Yeah, I think we'll call it that. So outline, and then you say like thickness. That'd be sweet. So with round, um, we might call it like expand rounded, or because you have to, when you use this round operation, you have to expand it. If not, every shape that we do, we have to like, or rounded expand, something like that. Yep, that's fine. Here's a wizard. Yes, mathematician. That's it. Absolute wizard. Thank you, Swang Funk. Thank you, thank you. Yes, custom theme based off of a theme called Ascent. I've just sort of extended it and made it a bit better. But yeah, so those are all the operations we want to do. So let's just get all the shapes in there. So I'm thinking that we're not going to be doing like a bordered, like I don't think we're going to be doing like a rounded. I mean, these are the where is my thing? This thing. So we went and did this sort of rounded edge here. I think if we want to do that, we just use rounded expand, right? Op on top of the AABB, because yeah, let's just do it that way. Now the thing is, wait, what's the thing? Yes. So remember we spent time to anti-alias it, right? And to anti-alias this thing by basically doing the sign distance field twice. We're still going to be doing that, but for every single shape. And you might think, is that unoptimized or whatever? But because we're doing it, we'll be doing it when we actually do the shape operation. We should be able to share a lot of the same maths and only repeat certain aspects when the size of the object is actually involved. So as an example for one of the things, where's oh wait, the 2D ones. So as an example here, like that's a length takeaway R. Well, obviously that length operation will only be done once, but this R would be different by 1 pixel. Same with this sort of like box here. B is the extent. Not so much for this one actually. Would we anti-alias a box anyway? I don't think we would. But with a rounded, when you make it rounded, yeah, you would. Yeah, I see that. But I want to make sure it doesn't. I gotta think you can't multiply. Yeah, you're gonna have to do it when the shape is made. Yeah. Okay. Are SDFs easy and fast to render? They're quite. I guess they could be like, you know, they do require a lot of compute the more complex they get. Like basically the circle is the easiest thing to compute. And you don't really need to. Oh yeah. It does require a square root here though. But we did kind of avoid that in our current implementation. But yeah, they do get quite hefty. You know, people make full 3D scenes with SDFs and things. But yeah, we're not going to be hopefully using too many of these complex ones. But yeah, like we'll see how it looks when we do a full screen of these things. But yeah, like just doing basic boxes and circles, like it's pretty fine. Like they're the yeah. If you want to do some more complex things, like you could use a cross. Like you can do a cross as well. Like the best thing about this is it's basically like a vector. You know, like rather than being like a bitmap, it's all done. It's all rendered in real time. So that's the benefit, right? You can scale it and do whatever you want with it. So if you have that in your application, that's the trade-off, right? A bit of performance, which on like a computer nowadays, isn't really too much of a problem. So there's like you can do like stars, for instance. You could do crosses. Wait, where's the cross one? Here we go. There's a little rounded cross here. It's not that bad to compute that. And that's all scalable. There's plenty of stuff here. There's a little plus symbol. And remember, you can add, subtract, union these things, and build whatever you want out of them. So it's pretty sweet. Like this website is a goldmine, basically. Right, so let's add a few little shapes that we want, and then we'll finish over do one take of the API, make sure it's everything we want, and then we'll. So we're not doing the rounded one we're doing it sort of like via the sort of rounded expand operation. The line segment, I guess, could be useful at some point. Rhombus. Yeah, I think just rectangle and circle is good enough for now. In future, we can just add more. Let's just do two shapes. And also the benefit of the way we're going to be doing it is now that we've separated the shape from the color, so we haven't done the color bit right now, I've just realized, is we can texture just a circle, right? That sort of thing. So then you can say color. So, okay. So you might say, simply just say color. Something like that. So you could also maybe say texture and you give it a GPU resource ID for a texture. For a sampler. But then you probably also want to have some sort of UVs as well. It gets quite a lot of parameters actually. So maybe you can say like, maybe there's two versions, right? So it will be like UV start. UV end maybe. Or you say like bottom left. And maybe you say like size. Something like that. Now I don't know. Yeah, maybe we'll pass in the GPU stuff here. But also another way we can do it as well is we can actually like, because when you try to color it in, at the end we're going to have a distance. So we can use that distance in how we color it. So really what you could do is you could say, right, we could basically do a bordered color on that whole shape, whatever that union or subtraction ends up making, and just border color the whole thing. So we could actually just say border, or like color bordered or something like that. So you have a standard sort of like inner color, and you have an outer color and a border color. And then you basically define the thickness. And based on the distance, right, because you get assigned distance, what that means is assigned distance from the edge. So it's negative when you're inside and positive when you're outside. So when you're inside, if it's obviously like, you know, say if you say the border is 10 pixels, well, if it's greater than -10 and less than 0, then it's the borders. We can give it one color or give it the other color if it's more than that. So that'll be super nice, but also you can do some form of probably a gradient based on the distance as well. So you can get it to say, you know, you can do gradients with that as well. But yeah, so there's different types of gradients as well. You can get it to be based on the distance, but also positional. Yeah, there's all sorts. Let's state for OpenGRP. Interesting. State for OpenGRP. Yeah. Yeah, it does. Yes. Yeah. Oh, sec. I see. Right. Yeah, it is kind of like that, isn't it? Actually. Yeah, a little bit. It's kind of like a tree as well, though, with the ops. Yeah, I see what you're saying. Very much so. Right. So I want to take another pass just to make sure, because this API, I guess, can be used by. It'll be used internally, but it can be used publicly as well. So the thing is you could say, yeah, I think it's better if you do it this way, actually. I was thinking, like, but the way we want to encode it is differently inside the shader. What we want to be producing is an array of commands. So, as an example, if I say something like union, and then and then I say circle, and then I say ABB, for instance, as a wait, maybe I say then another union, and then a circle. Right. So imagine you do this like union start, circle, ABB, union end, circle, union end. Right. How this will be encoded in the shaders is different. What it would actually be is something like this. Circle. Damn it. Circle. Yep. So how it'd be encoded is like this. It would say circle, ABB union, circle, union. And the reason is because this will get pushed into like the distance for this will get stored in like, let's call it register 0. And this one will be stored in like register 1. As an example. Then this union here, what this one's going to do is take the minimum. It's going to min and then store it inside register 0. And then this one will be register 1. And this one will take again and then union them together, right? So yeah, there's ordering stuff like that. It'll just be encoded a bit differently is all. But we can do it because we've got start and end is all. So we have to sort that all out. So the other way I was thinking about doing it is rather than doing it like this tree sort of way where we say start, circle, union start, circle, then ABB, then union end, you know, that sort of thing. Rather than doing it like that, I was thinking, why don't we just do it this way? Where you just say circle, circle, union, right? But then you got to be aware of this implicit sort of like stack. Like it's kind of like a virtual machine in a way. It'd be like a stack-based VM kind of. You got to be aware of that in the background, and that's not good. So if we just make it this tree, then we can catch all the errors basically. So that'd be good. So I'm thinking about also like prefixing it with shape and color that way. So I could say color solid, just a solid color, color bordered, that sort of thing. Yeah, it'd be good. Right, I really like that API. Should we get implementing that? And we'll make a nice. Yeah, so we'll make a nice array of commands, and then we'll have to copy that to the GPU afterwards. That's really nice. I like it. Rightio. So let's drop that one in there, include the UI UIs. And voila. So also include the game.h. Right, so we've got to have some form of state. We haven't got that any form of state yet in the UI, so we've got to sort that one out. Oh, sorry, I think Ransel asked, do I use pragmas once and not ifdefs? Yeah, we just used pragma once in this project. I know in HCC we used pragma once and ifdef, if not def, but let's face it, all compilers basically support pragma once anyway, so yeah, just use that one. I guess unless you're targeting some embedded platform, maybe. So we're going to include the UI, the public header. Bam. And we wanted to declare like basically UI. Something like this one. Oh yeah. So this will just be our super lovely global. So extern UI GUI. See what I did there? What might happen if you forget to call your end function? Yeah, we want to do a lot of like asserts. There's many things you could mix and match the ends and stuff like that. Yeah, we've got to call the appropriate end function. We've got to do. Also, if you put too many shapes in, got to capture that problem as well. There's loads of little things, but also if you don't call finish, yeah, so we've got to have like a state. Really keep track of that state. Rightio. So we need to have some kind of like, what is the state we're currently in, I guess, in terms of like the API. So in terms of like the UI API, right? So we in state is a very horrible word, right? We don't like it, but so what are we gonna do? So UI state, like we're in the state of. So if you're saying like draw. And do you push on a bunch of states as well? Because you say union then subtraction, you obviously want to be able to go back up that as well, and know which one to sort of like. So you can't simply just sort of like. Well, we could encode it directly inside some array temporarily. Like inside the array, we're going to be poking these members in. Probably not actually. Yeah, so we might have like an array, like there's only so many levels this will go down. So this sort of state thing is only for the draw API. I think him for like the control API when you, or like a widget API when you say button this, button that. You don't really care. So I might call it like a draw state, but the draw state as well, again, very sort of overloaded terminology, but that's fine. So I think I might take this sort of like draw section. So we're gonna have this sort of like so when you start, what state are you in? Well, you're kind of just you're expecting. We're just in the sort of the root. Maybe we can call it, say, like root state, like state or something. You're building like a tree at the end of the day. Then the other one could be like obviously union, or op union, op subtraction, op intersection. Op rounded expand. This is a unary operation, right? Single child. See, rounded expand is these very long names, but I guess it's fine. So an outline is another one. That's another op. Now, when you put in a shape, you're not really going anywhere. Like, you're just going to the next thing. And if the current state is maybe outline, yeah, outline, then it should kind of finish. Like, you should move to the state of. So I guess you could say union two maybe. I don't know if that's sensible. I think the list API would be simpler and less error prone. Well, when we did that list of API calls, you think? Oh, you're saying, and then Blizzak is saying do like a sort of scope API, where you have like a deferred scope. Yeah, that also could work. Deferred scope API. See, the problem with the list API then is kind of a tree of operations, though. That's the problem with it. Is it is a tree of operations inherently. But yeah. So what? So how would you solve that problem at Kraz? So it's like, you're defining essentially a tree of ops, and then it gets flattened out. Because we did mention that, right? That if you have like union and like circle. ABB or something. We did mention that it does get flattened out, right? So it'd be like circle. Well, it'd be the other way around, wouldn't it? Yeah. See, then you got to be aware of the state machine. But it would be better. It would be better for the internals of the API, right? But in terms of the users of the API, which would be better? And that count as well. Yeah, it's reverse, isn't it? So we could just say like union. So shape circle. But then you got to be aware of the aware of it. Got like an implicit stack going on. So if you would then add a new ABB, but then you kind of get the same sort of problem with well, okay. So if I were to draw something, we still need a start and an end. Right, we still need to say start and finish. Right, we still need this though. Right, because you need to be able to say, or maybe you don't. Maybe you just say finish. Right, maybe you just say, oh, we've done it now. So the idea is, there is a start and finish then. So maybe you just say, you just say shape, circle, shape, ABB, union those for me, please. And then you say shape ABB, then union that with the previous one. Now the problem with this is that if you call that to another function, obviously, in between there, that they could do some of that stuff. And all of that, and mess up your thing. What else? Yeah, so that's one of the other issues. The second issue that is it's kind of not, depends how you look at it, right? It could be a bit less. Let's try and compare them. So it'd be something like that instead. I guess you would like maybe tap them in a bit. But again, equally, you could make it like one of those sort of like deferred, those sort of scoped things, and you could do this, right, with macros, with holy macros. As so I don't know, what do people feel? Because you could scope it out like that basically. And that's how the API could end up being. But then you'd have to make a lot of, if you did this, you would still, you did this, it would still be happening this way, and you would still need to keep in the internals keep track of the state just in case it gets modeled up a bit. Whereas this one should be able to be encoded directly inside a buffer somewhere. Just poke it in. I don't think there'll be too much error checking really. Except for if you overflow something. So my other thing as well is like maybe in the future you might want to make a quick editor that just allows you just to like basically use this draw API. Like draw, like just be like, oh, I want a circle, right? And then you can sort of like put them on the screen and get them and like make the shape that you want interactively. But with that, this still works. You can imagine it's like a list of commands and you just put them in there. Yeah, maybe we do this. Yeah, it'd be better, I think. Because, yeah, let's do it that way. No underflow. Yeah. Let's do the implicit stack thing. I know I didn't like it at the start, but I think it should be fine. Well, I thought this would be better. It's not that I didn't like it, I just thought because of the implicit stack it makes it hard. But maybe, yeah. So we'll do a count still. Which would be pretty interesting. Let's do it. Oh yeah. So it means we just need a finish at the bottom, like that. Right, that does make it a lot more simple. Righty. So we were, I don't know if we need this draw state then, because you're just gonna literally just encode it directly in there, which would be incredible. So basically what we want is like, we want some form of buffer, really. So we kind of, in the shared place, we want to have like, so it's going to be, the way I imagine it, right, it's just going to be like some opaque, well, some piece of memory that we write different data structures to, and depending on obviously there'll be a header, and what comes after it is depends on the thing we're yeah. So each of these will write like a little the same header with a different type, and then the data that comes after depends on the thing that's there, basically. So right. So should we edit the draw command thing now? Keep this thing open so there's some lovelies. You need to check the stack representation anyway with the tree API too, right? You can add the tree API later into which would use this API. Yeah, I don't know if I would do the 2-layer. I think we'll just keep the stack-based API. Yeah, I think there's not enough. There's not enough. Like, I usually like. There's not enough layers in, but like, there's not enough room to sort of warrant another abstraction, I think. Yeah. So I'm just gonna go with the one API. Yeah, definitely. But I think it might be cool in the future when we want to demo like making some fancy like things. We can just do a quick like editor and just sort of make the shape that we want, export that out, and just as code, and just copy paste it in the code base. It should be like proper easy with this as well. And it shouldn't be error prone, I think. You just have stuff dangling off the end. Yeah, exactly. We wasted effort. That's right. Cool. So I think we're gonna basically butcher the crap out of this. Right. Let's do another one. Let's call it like, yeah. Let's do another one. So this is shared between CPU and GPU. We'll call it draw type. Bit different. It's not a command anymore. That way, when we say draw command, people are not like, what? So ABB and the circle. Whoa. The next thing is we basically need all of these buggers. UI draw type. So I guess these will just be your super lovely shape. These will be your super lovely ops, right? Operations. And then you also, so the color, like, so like you could stack the colors on top of each other, right? You can say, hey, like it will multiply. So maybe by default the color is white. So by default you start the color off as white. Wait, do you multiply it? That's the question. Yeah, you multiply it, I think. And then that way you can say, oh, I got a, you know, fetch the color from this texture, but then also multiply it with this solid color. I don't know. Yeah, I don't know much more. Like, if we support any more operations, then it gets more switch statements, right? And I think we'll stick with multiply for now. We'll see how that goes. I think that's a good route. So we'll do the colors as an op as well, as a one of these things as well, right? Sweet. This is gonna be so cool. UI draw type. And then we'll do a count at the bottom. Fantastic. Oh yeah. So now, so we're gonna have a bunch of different like we're gonna have a header. So this is the thing that just gets pulled out every single drawer. And it's just gonna have a type in there. Oh wait. Sorry, it's not gonna have a type in there. Oh, this might be called draw command or something, but we'll think about it. So you initially have like this. Yes, you have a header, and inside the header is going to probably be like. So this is on the what is useful on the GPU. You kind of need to know. You need to know the size of your box, and you need to know that for when you do the texture, I think. Yeah, only when you do texture, you need to know the size of the box. Or the size of the... It's only when you do texture, you need to know the size of the box. So you could encode that in when you do texture only. So I'm thinking when you first start these things off, okay. I don't think there needs to be some general data that's sort of shared amongst them all. So it might just be the type that you need to look at. So you pick up a type and then you just look after that instead. It's all going to be 4-byte aligned information anyway, so you don't have to worry about anything. So yeah, maybe it just picks up a type. We just roll from there. Right. So we're just going to have like a draw buffer basically. So we have like a draw buffer size. So probably include define UI draw buffer words cap. How many words? So we could say 16.384 maybe, something like that. If we go over that, we're probably gonna go over that, but let's just stick with that for now. So we'll probably just have like a buffer of maybe like what is a void star? Draw buffer words. And the capacity is going to be fixed. So the idea is you'll fill it up and then you give it to the GPU. So you just copy it out basically, and then the GPU will copy it to one of its buffers, I think. Sweet. So with the UI system as well, we do kind of want to have like a way of initializing it. Void UI init. Yeah, I don't know if we're going to have much more than that for now. Okay. So all we'll need to do is get hold of the static allocator, which is in game. So it's game TLS static allocator. And then we want to allocate ourselves GUI dot draw buffer words So that is core alloc array of U32. Right, static allocator goes in, and the number of words. Alright. Oh, we didn't declare our thing, did we? Oh yeah. So the plan is, let's start with finish. So finish is literally just going to say GUI dot. Wait a minute. So we might need another array. So you need to sort of, we need a name for like, so when you draw something, you need to have like the start index somewhere basically. So we need two buffers. We need a buffer for the kind of like, I guess, draw commands, maybe. Maybe not buffer words, just call it draw words. So there's sort of like a commands array and have like draw words. And it's just a bunch of U32s basically. Ooh. Oh, yeah, we do. That's a good point. We want like a frame initialized, don't we? That's a very good point. So we need to reset those. So when you say GUI dot equals 0, oh, it's not buffer words anymore. Let's change that. Words and then commands. Oh yeah. That'd be good. That'd be good. Oh, my tea's all gone. Oh. So when you finish, you kind of just want to like add on another array of bounds, right? So the array of bounds is GUI or GUI dot draw commands count given the number of commands that we have. And we're just going to insert into that array, right? Command. So I've got to remember where that command was. So you want to have like a U32 draw command word start index. So by default, that has got to be -1. So when we start the system, make that U32 max. Okay. So what we're going to be doing is saying, right, GUI so the thing is like when you do a finish, do you just poke in a finish op? Yeah, maybe you poke in a finish operation, and then when it reaches finish, it just ends. And you make it 0, so it's a bit safer, I guess. That's a bit of fun. Yeah, sometimes like the API that's just simplest to implement is just the more correct one to do, you know. Draw commands, and you do +1. Then you want to set this one to U32 max again. Now here's the thing. We want to do a little bit of an assertion to say, you know, you can only finish something that's been started. And, you know, it is kind of still error prone. So we do want to keep track of like a stack just to make sure that you're doing this right. These guys right. So we need to keep track of that as well. So internally, maybe we just do a couple of like defines up here, I think. So you say like UI debug assert draw has started. So that's just going to be a core debug assert. That GUI or GUI dot draw command word is not equal. And we just want to say like expected. So you just want to say like draw UI. So you want to say like has. But you only really want to use that on the finish, maybe. Whereas the rest. Yeah, maybe this one you don't need anything. This one's just down here. Draw finish can only be called when something has been drawn with. Obviously you could just put the draw op in there, but it's not going to be useful. So I might want a nice little internal function, and we'll call it like draw. Draw word push, maybe, because we were putting a lot of little words on. And we could probably do a few of these. Draw word push, and so you can just say like push singular, and then you also have push many, and that's words word and then count, right? So you just say start, and voila. So we'll put these on here. Pretty easy. So obviously singular word. We've thrown on like a finish, right? This would be word. Fantastic. So as an example here, we're going to be encoding. So we could encode an end, but it's just as easy just to write a finish, I think. So we encoded a finish versus just having like a range of commands that it does. No, the range might be better. Because if we did a range, then we could pack it into a single U32, and then there'll be one less item to switch on, I think, as well. So up here, we'll define like a UI draw command. So that'd just be like maybe the first 24 bits, and then the 8 bits can be used for the words count. So you can encode one words start index and then words count, something like that. So this would just be like command shift right 24. Sorry. Wrong way around, but we'll copy and paste it. And 1 byte, 2 byte, 3 byte. It's like 24 bits, right? Something like that. That'd be nice and ideal, wouldn't it? So so I guess we can like type def this as, and all of this just unfortunately can just be if def down. So that's all the old stuff. Yeah, this is gonna be sweet. So this would be draw commands. So there's those lovely U32s. There we go, that one there. Sweet. Didn't do the shared. Include UI shared. That'll work. Okay, so the finish no longer pushes on a finish thing. Instead, we want to encode like, oh, how many words did we push on? So we need a few little things, right? So we also need like a word start index, words count, and then yeah, we wanted some more, but let's just start with those. Right, so when you push on your command, like we should kind of do a nice little surgeon here, just in case, right? Debug assert that. So if you go over like, first of all, this has to be less than well, the way you can check is if you chuck it in and then you try and see if it's equal to the same thing. That's probably the best bet, isn't it? So we want to encode it as a draw command. So that'll just be UI draw command. You encode it as this and this. And then oh, did I not do it? Don't mind me. So that'll be something like this ANDed with this, and this one shifted left by 24. Right, anyway. So I think the idea is like, well, if we just do that on command and make sure it's equal to that. Words start index overflows 24 bits or something. Then this one would be count overflows 8 bits. Oh yeah. So what's going on? Did I put a semicolon in there? Oh, I didn't. Very nice, very nice. So, right. So now we need to push that command here. So this pushes onto the commands, right? So we sort of just say like, create draw command and sort of like validate. And then here we just say push on the draw command. And then we just reset the state here. Reset. Right, very nice. So that's when you finish at least. So when we push, we also want to make sure we push on this one as well. Draw or increment this by 1. So this is draw command words counts. How many words from the draw command? Now, you definitely only want to be able to push some words on when this thing has started. So to make this so we could keep calling this push API. So the only problem is, right, is I've got these sort of like F32 times 2s. So it kind of would be more efficient if you just copy them together, or one after the other, then increment these by 2. And that's possible. Maybe just by using like a for loop or something. And we'll probably have some convenience functions for those as well. So what you would do then is you would say count. And you probably use the resize one instead. Then you just do a for loop. Hey there, Dr. Merrick. Hey, I'm back. You wouldn't believe the reason. Oh my days. I removed XML2 link output. I no longer need those 2 lips from FBX. Yeah, I don't know why that would be the reason though. It's very bizarre. Isn't it like a partial compilation maybe? I'm still a bit confused, you know? So technically that should probably be better. But maybe not. In debug mode, definitely. Yeah, I'm glad it's working too. Now you can move on and do better things. That is horrendous, not gonna lie. Right. So that's pretty good. So that's the lower foundations in. So now let's start implementing these dudes. Right, these ones here. Now these require a notion of a stack. So we need to sort of keep track of some form of like, yeah, some form of stack. for checking basically. So you kind of want to have like a draw. So these want to be like operand stack or something like that. So this is the stack that's sort of in the shader. So a union expects there to be two operands on the stack, basically. Oh wait, we need some convenience functions, right? Address of V casted to 32 star 2. Oh yeah. So to do a union, like firstly, core debug assert count has to be greater than or equal to 2. Can only union 2 or more distance. Something like that. Distances. So the other one is like, you've got this like op, right? This draw operand stack op. You want to make sure that this is greater than or equal to the count. Can only union or like there is not enough operands to union on the implicit stack. So this one's going to end up basically just pushing on a word, which is a count. Wait, no, you push on two words, right? So you push on one word to say, oh, you got yourself a... So you push a word, and the word is going to be the UI draw type op union. And then the other one is going to be push... What else are we pushing on now? The count. Because that'll just be a for loop in the shader that just basically mins the top of the stack, basically. And then puts it on there. Puts it on the stack. So what you want to basically do is say, right, GUI dot operand stack. This just gets reduced by count -1. Yeah. So you... Yeah, that's right. So say if you're union two shapes together, you take the two distances off the top of the stack, min those, and then put 1 on. So it's 2 take 1. Hey, buffer overflow. How you doing? Welcome, welcome. Oh, there's another thing as well. Is when you finish, you want to make sure the operand stack is exhausted, right? You want it to be huffing and puffing. Operand stack equals 0. And also, like, you want to only be pushing on what if you have words, right? So, like, so UI draw finish cannot be called when there is still operands on the operand stack. So yeah, I think we've got to question it when it comes to colors, but I think about it, let's write the implementation and we can always change it a bit. But we kind of want to be like, oh yeah, you can also only do it if there's actually any words. Oh yeah, but you'll get that anyway with this. Interesting. So you kind of want to do a thing. Maybe you have another function where you basically say like, start if draw I don't know what to say. It's like UI draw maybe implicit start. Yeah. So with the implicit start, we kind of say, oh yeah, if this is equal, then can we set it to whatever the current end of the array is? So that would be, which one is it again? Draw words count. That's what I want to set it to, right? That's how you implicitly start it. Then you want to set this one to 0. But finish would have done anyway. So you kind of want to call implicit start on everything. Right, implicit start. Also, are you using like a build system there, Dr. Marek? Like, are you using a build system at all? Like, I feel like it could be some caching problem, maybe. I don't know, it's weird. Weird issue you had. So for subtract, it has to be two. It has to be two distances. Right, so it's like this code here. So the count is just 2. You're not pushing a 2 on there. See, also with the unions and that, there's also like smooth versions of them. We can always add those in, I guess. Let's just get the initial ones in. So minus equal 1 on the stack. There's not enough operands to on the implicit stack, something like that. Bam. Intersection is basically the same. Oh, I didn't subtract. That's good. Union. Sweet. Rounded is only 1. And with rounded, you want an extra operand going on there. to do a rounded expand. So this one isn't going to change the operand stack at all. It's just going to take the last distance off and just change and put it back. It's just going to modify the last distance. But what it is going to do is add another word on, and that word is the amount. So that's got to be so maybe you say like push U32, push F32, and that'll make it a little bit easier to understand, I think. 2 seconds, my wife is calling. Hello everyone, welcome back. Sorry, I had to pop out and do something for my wife. She needs some help. Just getting the chat back up on my phone. All right. It's good. It's back up now. Okay, so where were we at? So out of this implicit start when yeah. Ooh. Yeah, it was changing this thing around, wasn't it? Wait, which one of these was the internals? That one. Good. So we added these two to make it easier to push them on. Well, it kind of just calls into this one really. The DRF. Something like that ought to be good enough. Nice one. So that means when we do these pushes now, thank you, sorry, thank you. Pushing a U32 count on, pushing a U32 count on, and an F32 amount. That's what it's doing, rounded expand, right? It takes one operand, and that is the amount. It's kind of like this, the amount we're expanding by. So outline is going to be the same sort of thing, right? We kind of want one distance operand. Maybe we should call that distance stack. Stack of distances, right? We'll think about that. This one is the outline. Outline. And that has a thickness. Very good. Cool. And then got these shapes. So these shapes are, require something like this. They don't require some operand stack, but they definitely do. Wait, what did the rounded? Yeah, they just modify the distance. Yep, it's good. These actually put one distance on these shapes, right? They add a distance to the stack. So this is a shape. So we need to put on the center position and a radius. And then with the ABB, it's pretty much the same, but you just do a half size. So basically, we just got this array of words that we're just gonna be able to like pull off and reconstruct in the shader and get these operands off. Or get these words off, and then do the sign distance field from there. Basically, it's not going to be too difficult, right? Now the colors is something I haven't really thought about. We've got this sort of operand stack, but where do the colors go? Oh no, there's just a general overall color isn't there. It doesn't go back on the stack. That'd be a bad idea. So with the coloring, you kind of just want to, I think you just want to do, well, with the color, you kind of care that something has started before, right? See, I do want to have this thing repeated and shared maybe, but oh well. Can only be called when something has been drawn with draw. But you kind of also only want to do it when it's been finished. And if you don't color something, it just defaults to white. Yes. So actually what you want is like a color assert, I think. Probably a sensible idea. Probably a sensible idea. So that color assert. Nice little assertions in there. So we want to make sure UI color star can only call when something's been drawn with that, and UI color star cannot be when there's still operands on the operand stack. So I think we should really rename that. That's like distance stack or distance operand stack or something, because it's just gonna be for distances. Right, so do that assertion. Then all you're doing is you're just putting on the words, right? You're gonna say, oh, it's a op for color solid. Oh wait, sorry, it's color solid. Did we put those on there? Yeah, we did. Color solid, and then chuck on the color for me. Color. And then the texture one as well. Implied. Do we want to do like implied 1, 0? No, I think we'll just. Right, so this one, it's going to be U32, but we want to use the GPU resource ID index to convert that resource ID to a something else. Oh, so that's dead crap being in here. Into a resource index, which is passed into the shader. Why did I do a comma there? Not good. Sweet. So then you want to implicitly place, or place on the implicit UV arcs. So just be 0 and 1. Now this one down here is basically, ooh, oh, that's texture. Oh, texture UV, that shouldn't be a separate one. Keep it all the same. Yeah. So this will obviously just be UV bottom left and then UV size, I think. We'll see what happens when we actually program it up. And then this one is inner color, border color, border thickness. That'd be good. So that'd be bordered. Inner color, border thickness. That's an F32 there. Fantastic. Right, so that's the API all filled in. So now what we have to do is plug in these initialize and frame starts into the right places. So we need to go into the main file for that. So we're just going to chuck it below the graphics, maybe. I don't know. Well, after the OS or something. I don't know. Kind of just logical side of things. We'll see. Anyway, just do that there. Bam. And then we want to do the frame initialize in the. Get past all this. Let's get to our main loop of the game. Oh, sorry. UI frame initialize and kabam. What is? Yeah, shortened for allocator. Yeah, it's just my little way of doing it. It's just short for allocator because it just gets a bit long, and I use it everywhere. You know. Oh, we don't include the UIs, do we? Let's do that. Oh yeah. Fantastic. So now all that's not working is the shaders. So we haven't actually got anything. So we'll need to reconstruct the CPU side. Right, so we do a render frame. Let's just be quick about this and just do something like this, right? UI, draw, circle. Center position, I'm glad you asked. It's this guy. And the radius is, let's just say 200. Okay. And then we're just going to say finish. Now, something that we haven't sorted out, I think, is you shouldn't be allowed to say circle, circle. Wait. If you say circle, then circle, and then finish, that should be an error somehow. Oh no, it is already an error because you've got 2 on the stack. You should have 0 on the stack. Yeah, I think that's fine. So the thing is, not so red, we're doing the type checking in the AST. So it's astgen.c, that's what we do. But it's because it's single descent, isn't it? So we just simply, there's a function called like, see, in C it's a little bit complicated as well. What the hell? Yeah, so HCC source HCC if we're going to the internal header, it's in astgen.c. So it's astgen underscore type or check compatible assignment and check. Now this is under the expression level. We check compatible assignments and check compatible arithmetic. And that will do the integer promotion and all the silly stuff in C. But it's simply just checking for the yeah, I'm not sure if this is a good reference though. Yeah, I'm not sure if this is really a good reference for the stuff you're doing. Purely because C is done when you parse C, like everything is already declared, so you can do the type checking in line. Whereas for you, it's all out of order, so you have to delay it. But you're simply just checking the data types, make sure they match or are compatible, basically. And you know, when we construct our compound data type in our structure, all the fields should already be declared, so you can do the type checking in line there. Whereas in the language where it's out of order, you have to do it in a separate place, right? That sort of thing. Right, why don't I see it here? Because it... you know what, let's move this into the game now. Screw this thing. Wait a minute. Wait a minute. We need the UI in here anyway. Because we need to be able to say, hey, give me that draw list in a way, right? That draw command thing. So what you want is some form of like, hey, can I get the draw commands? Can I get those things? So that'd be like UI. Do we want like a pointer? Ah, man. So I do these things different every time. Something like that. Right, how many draw commands you got coming out? And then you also want to get the words. Draw words. So the GPU API needs to use this so we can copy those in, yeah? So that would just be like, hey, return G, GUI. Count out equal GUI dot fantastic. So what we want to do no worries, that's cool. No worries. No worries at all. Yeah, so I think we've got to use the API in here anyway, so we will just include ourselves a lovely UI. So we're gonna uncomment all this again. Or not again, just uncomment all of this. Sorry, comment all this out. English. There's no shape finish, of course, because it's just a finish. Right, so just put a circle on the screen, finish. And instead now we're going to get some different buffers, right? So you see, you've got this like commands buffer. We need another one of these guys. So also need a word buffer as well. Words buffer. Now we get this from the UI now. Just a direct copy. So UI draw commands cap capacity times by that, please. Is that inside? That's in the internals, isn't it? Let's get that out of the internals. Get that into the publics. And then what you want to do is do a similar thing, right? UI draw words. These are the words of the draw command. Times by E32. Bam. Right. Got those two lovely buffers now. Now we've got to populate those. So every frame, after we've done with our UI, we want to actually just do a lovely little upload, right? Something like this. Upload buffer. So for the commands at least, UI draw command star draw commands equal UI draw commands. So then you have E32 draw commands count, address of draw commands count. Something like that ought to be good enough. Then you do the same thing for the words. So rather than commands, you just say word. Sweet. Nice. So that should put the stuff on the GPU. So we could just start by literally just doing the circle one again. On the GPU. So all the data should be there and available. Every frame is upload the whole thing. Obviously, when it comes to like multi-threading, getting the render on a different thread, there's going to be some changes we'll have to make, but it shouldn't be too much of a big deal because there'll be like, a handful of systems to do that for, and not like thousands, right? So it'd be really easy. So here's our UI render shader. Okay, so there's a different thing we want to put in here now. So rather than yes, there's an array of these draw commands. Yes. And then there's going to be this thing called a byte buffer. So what is a byte buffer? So a byte buffer is like, it's kind of taken from like HLSL with that byte address buffer. And what it allows you to do is basically like pull out words of, see, really byte buffer is a bit of a kind of wrong way of saying it. Maybe I should rename it, but pull out words of 32-bit integers. And I've got some convenience functions to construct like vectors and things. So you can basically like you can pull out like, it's like having like a void pointer in a way. And you can sort of like pull out any bits of data that you want, but they're kind of like restricted to being 4 bytes in a way. Although you could construct 64-bit integers, you just grab 2 4 bytes and stick them together. But yeah, we'll think about it. But anyway, here's the words. Ta-da. So don't think we've finished with the GPU actually. There's a few little bits. Crap. This needs to go out here like that. No, I don't know if I have to disable them on the... I don't have to disable them on my shader files, no. It's it can pick it up because it's just header files and it parses the header files. It's nothing non-C. Everything is defined on the CPU. That's defined in the shaders, basically. Is that right? Yeah, so the only thing is like specific functions might be declared, but they don't have an implementation. So like maybe like sample texture, that sort of thing. I think. So yeah, this thing is, yeah, and this thing is defined, but it doesn't do anything on CPU. Just empty. So it's pretty good with that sort of stuff. Cool. See, I think we can just start transforming the crap out of this now. So we're gonna have like an implicit stack. So there will be like a stack size. We need to declare that somewhere. So in UI shared, we need to have like, so you call it like an operand stack. We should call it distance. Distance operand. Distances. Draw distances operand. Or should we draw distance operands stack? Maybe, yeah. Draw distance operands stack. That's a little bit more of a mouthful, but it's more understandable, I guess. So in the shader, we want to have that stack, right? So we need to have some form of define up here, which is like UI distances operand, distance operands stack capacity, and the capacity is going to be maybe all you need is 8, but we'll see. The lower the better. We're going to change this number. So it's just U32 distance operands like that. Voila. That's going to be good. Do C implemented functions get inlined? So every function, when you compile it as a shader using my compiler, gets inlined. It doesn't get inlined specifically by my compiler when you give it to spivvy op, which optimizes shaders, or if you give it to the driver, they basically implicitly inline, or they inline everything anyway. So everything just gets inlined. Because you don't have any recursion in shaders. Right. Sorry, 2 seconds. I just want to check on something quick. But yeah, I'll be back in literally just half a minute. All right, welcome back. Cool. So along with the stack, we also want to have like a distance operand index. So the CPU should guarantee this never overflows. So what we're just going to quickly throw in is that check. Right, so when we modify this, when we add, so with the shape basically, right? So we kind of want to have like a, so every shape adds 1 here to this stack. So you probably want to have like shape shape end or something like that. Right, so you call it the end of every shape. I don't know the name to be honest, but it should be fine. So the shape end is going to take that operand stack, add 1, and then assert. Then assert that this is less than or equal to so that is actually a little bit weird. So draw distance operand index. That's what it should probably be called. So we just want to say like, whoops, this shape overflows the operand. Distance operand stack. So we should probably just rename this to draw distance operand index. That's a better name. Sweet. Pretty good. So every time we end a shape now, so you get shape circle, we call this function instead of doing that. Oh yeah. Very nice. So when we in our shader, right, this is guaranteed not to overflow anymore, providing the API is used, right, which is basically impossible otherwise unless you include the internals. Or you pass in bogus data. You know, if you upload bogus data to the GP buffers, right? So you've got the number of draw commands here. So you go over every command, and then you've basically, when you decode it, you've got some words. So you say U32 words start index equals UI draw command word start index command, and then words end index is plus the count, right? And now we could do a nice for loop. So I kept my for range actually, so we'll do it this way. No biggie. So I have a word index. Wait, do I want to use a byte buffer? Because byte, it's really like a byte address buffer maybe. Yeah, we'll just do it, you know, we're going to do it as buffer. Do it like that. It's probably better. Probably better. We'll make some convenience functions to extract commonly used types. So equals word start index equal word index words end index. Fantastic. So you extract one word. So I think we'll get the extraction functions in here. So we basically want to be able to say like you know, U32 GFX UI word U32, and you pass in, we need the buffer, so it's a buffer U32 of words and its index. So this one's like the easiest, right? It's literally just like return words word index. But we're just in that because then it keeps it the same as all the others. The syntax the same basically. So this be, there's a way to say like, oof, bits to, is that right? F32 to E32, is that right? There's a conversion function. Completely forgot it by the way, but so third party lib, HCC lib hmaths scalar something. So is it like bits to Yeah, bits to oh underscore, okay. Bits to underscore. Wait, bits from. No, bits to F32, that's it. Oh, so that will basically do reinterpret cast for those C++ people from a U32 to a. So it's like doing a. Yeah. So it doesn't. Yeah, so it treats the U32 as if it was like the bits of a F32. Then we want to do it times 2 so you get a vector 2 basically. A float for me, please. So for this one, +1. Fantastic. So that's all the stuff we want. The convenience functions that we want. So let's go ahead and do all that. So there should be a draw type. We just extract that out, gfx UI word, U32. So we pass in the words buffer, which is BC UI words, something like that. It's at the top, innit? Oh, that's right there. I don't know why I didn't pick that up. Right, UI words. What's the word index? What's right here? Word index. Ta-da! So it's saying +1 here. +1 isn't probably not like good, right? We should probably be adding this ourselves. So instead, we should keep this. Right, refactor this one to a while. Delete that. And take this, put it under here. And voila. Then we switch on the type. Okay. See, we forgot to do a color, didn't we? But the implicit color is a white, so that should be fine. So let's just start off with the most basic one. That was the circle, wasn't it? Okay. So I want to make sure to do anti-aliasing as well. Right, so what do we need to do with this circle? So we did this sort of like AA thing before, and it was kind of optimized because we didn't use a square root, which was pretty cool. But with this one, because we actually want to do a length, see, we could always give a squared length. We always gave a squared length. Yeah, but then when we want to do some of the operations, it might not be good. So let's just do the unoptimized one, and we can always change it as time goes. Iron Zero Maiden. Yeah, the question was asked about like the custom C shader compiler we've got. I think that's what it was in reference to. It's not a regular C compiler. Yeah, where shaders always get in line, you know. Or for functions they do. So this one's just obviously like length. So len f32 times 2. So we need to extract that out, right? So when you do a circle, we've got a center position and a radius. We need to extract those words out, right? So f32 times 2, center position, center position equal UI word, f32 times 2. We're extracting out, obviously, using BC UI words, and at word index, obviously, right? And then we want to extract our radius. So that's a +2, radius is a +1. We extract out radius there. Ta-da! And then you want to do a length op on the, so you do the difference. So you do like, do you want to keep the comments? I guess so. Some of that diff. You do length on diff. And then that wait a minute, am I getting this right? Length on diff. Diff. So you got the center position, current pixel. Oh yeah, then you check in if it's inside radius. So we take radius. And that'll give you the signed distance. So that's the distance that goes on the distance stack, right? So to push it, you simply, just do this, right? So you go dim. Yep, and then you add 1. So we'll be seeing a lot of that code. So push down the distance stack. Wait, don't you want to leave like one distance on the distance stack? Because the color should take it. Yeah, you should always leave one distance on the distance stack. So when we say this UI equals 0, crap. It should be equal to 1. Cannot be called unless there is only one distance left on the distance stack. Now that's what we want. The assertion, awesome. So you leave that. So we just want to do circle for now. Now the question is, what do we do? So you got a color. Right, so you take after you've done all the words for the command, you get the distance of distance stack 0. Always 0. You could do index, but it's kind of wrong, because that'll be invalid data. Now the check would be, you've passed if the distance is less than or equal to 0. Now we're not thinking about the anti-alias thing that we've done before as well. We are going to be doing that, but we just want to get this new version up and running. So if you've passed, you kind of want to do this sort of code here, where we do this sort of front to back blending, right? So now source color hasn't been seen anywhere. So what should we say about source color? So source color by default is going to be equal to white. Now with source color, right, so you start off as white. So when we come across a draw type of color something, it basically multiplies with that source color, and then we get the overall color at the end that we can apply here. So I think this is great. I think it should be fine. All the living crap is happening here. Oh crap, did I do it ×2? It's not called your words. What's it called? Oh, draw words. Don't mind me. Right, so shader's compiled first. Now the game is compiling. Right, everything's compiled, all good. So we're going from this like thing that we used to have, but we've now written a render like a draw API, which allows us to sort of like rather than have a fixed array that we used to have. So we've just commented that out. This is the fixed array here, which did all these different types of circle, glyph, and all of that. We've made it into a nice sort of like command API, so you can sort of like just call it and it puts the commands in, and if it's wrong it'll let you know. So I've only started off on the basic, just saying here's the shape, and finish. It should be a white circle that's got horrible aliasing everywhere, and we're going to obviously bring back the features that we had, plus more with all these super lovely SDF operations, so we can make all these beautiful shapes, and we'll have all these lovely colorings in as well. Yeah, goodbye example. Let's see how the right, we're back. Oh my days. Alright, apologies for that, people. Guess what? AMD drivers and bindless. If you make a mistake, it crashes your whole desktop. You know what the mistake was? Nah, didn't lose anything. And maybe the recordings are probably going to be a bit messed, but it'll be fun. Hopefully Twitch jams them together into the same stream. So, all that happened is this, right? We've got this super lovely... where is it? Where's our shaders? These guys. We've got this super lovely bundle constants here. But guess what? We added a new one of these in, right? Which is a buffer. This is just an index. And then on... we've got like this array. So we basically have like an array of descriptors, right? And we have an index into the array of descriptors where the buffer is for the words, right? These guys, these draw command words. So access is this, right? But this is not set yet. Oh, wait, sorry. wrong way of saying it. We've got an array of descriptors, right? When this thing is created, it's uninitialized, right? It'd probably be safer if we zeroed it. But it's uninitialized, meaning this is uninitialized memory. So what happens to the index is that it could be some big number. Say we've only got 4 descriptors, so 4 buffers, and you've got like some really big number, it goes out of bounds and crashes the driver. It probably grabs some other memory and then it's just, yeah, goes haywire. Oh, okay. But yeah, that's the Problemino. So basically we should zero these buggers, but then if you zero it, you're probably grabbing an invalid descriptor anyway. I don't know what is better. So I think we're just going to zero them. And if we encounter this problem again, then we know we cannot be saved, even if we zero them. But I think, like, I just don't want to test it out. I think when I turn off the stream, I might test it out actually, but not now. So, words, get the words buffer. I can't believe I missed this. Anything else before we completely bug things up? All right, we're good. Hopefully. So let's give it a run. Ta-da! Here it is, the horrible aliased circle, but we did it. Right, so there's the new API, but it did just crash, right? So it says UI finish. So obviously there's more distances for some reason. So this draw distance operand index doesn't get reset to 0. So we've got to go ahead and sort that one out. UI.c frame initialize. Wait a minute. What are we talking about? So when you finish, you should also be setting the operand index back to 0. Fantastic. Oh yeah. There we go. Profiling. So that's really cool. It should just be really easy now just to like drop the box in, drop the color in, right? Like that we had before. We've got a bit of time. I'll stay on for a little bit longer, and we'll get some more bits and bobs done. So so we've already got like ABB. Let's see what happens if we try this, right? So if you say like, oh, maybe do like a wide one, like 400 by 200. And run that, it should crash. Good. So it's crashing here saying cannot do a finish unless only one distance left, because you got 2 distances on the stack. That's bad. Yeah. So we just want to make sure that. So now, yeah, we're going to union them. Exactly. So now we do a union. How many are we union? 2. So that obviously didn't work. Why's that? Well, it works CPU side, great. Why don't it work GPU side? Because we ain't done it yet. So let's quickly just throw these buggers in. AABB. So there's a lovely implementation right here. This is how you do a box. So we've got to extract our shapes, shape operands. So it's just 2 of these guys. Right, center position, half size. So that's in the word buffer, extract those two buggers out. Very nice. And what is in next? So we need to get P, which is the difference, basically. So the way these sign distance functions work is point is relative from the center of this. Right, it's a vector relative from the center of this, and B is the extent in this case. So the half size, as we call it. So we calculate the diff, voila, based on, take a difference between the pixel we're trying to render and the center position, and it gets you that thing, that vector, right? Well, yeah, it's the absolute vector. And then, so it's simply just like, well, a subtract of diff by half size. That gives you this thing called D apparently. So that'll go on the distance stack. Man, this thing is great. It's gonna be so good. Length f32 times 2. I want to do a max s because we're a scalar. So D, which would then be f32 times 2. D f min f32 with a max f32. And voila. Right, let's give that one a go. So we could just put that in, but it still wouldn't work because we need the union to happen. So let's get the union in there as well. What sort of order are these in? Okay, union goes above. Okay. Now the union. So what the union does is it just takes the 2 off the top of the stack and does a min. So you basically get like a D1, D2, D1, D2, so that'd be a take 1, take 2, something like that. Hey Soulphone, how you doing? Welcome. Hope you're doing good. So this is just going to take, so distance is pointing to the place you're inserting. Oh, there's the count, isn't there? Good point. Yeah. Thank you, I completely forgot about that. Hey there, Wajilla. How you doing? So just gonna do a little. Awesome, good to hear. Go invite to the Jai beta earlier. Awesome. On the 10th. Request. Wow. Yeah, poor baby. Yeah, he's crying. Might go and check in a sexy other tune. Yeah, I think he's a hungry boy. I think he's a little hungry boy, you know? Like his daddy. Always hungry. So this is how many that we're going to be merging. I don't know if this is a good idea. Should be a good idea. So you're basically subtracting like count, take 1 off. So you basically have a distance. So what's the biggest distance? Infinity. So you always take one off. Good catch, good catch. You take one off and you just use that to get the distance, call it D. Distance equals min F32 distance. And voila. Something like that will do. Right, I'm just going to check on the baby. Anyways, 2 seconds. Hey, hey, hey. Yeah, so the baby's all good. It's just being changed, you know. It's a weird experience for him. Yeah, it's doing good. He's actually getting pretty good at the nappy change right now. Like, most of the time he doesn't cry, but it's just sometimes. It's pretty good. So the union means you take the word, get the count. See, I don't know how good this of an idea this is, having a variable count, but it could mean that we compress the amount of words that we have, potentially. I don't know. We'll see. So you get the count, increment it by 1, get the distance, take 1 off there, go over all of them. While you're doing that, you grab the distance. You need to take 1 every time. That's it. Min the distance, then you poke it back in. Give it a good old poke. So let's think about that for a sec. So if there's 2, oh yeah, then you need to up it by 1 again. Right, you go over it twice, taken 2, poke it back. Sweet, so I think that should be it. We must have infinity. I think we had to suffix it. And D, obviously. And voila. Give that a go. Right. So it looks like they have unioned. Although I was hoping... What have we done? 200. I meant to say 100, 200. That's what I meant. There we go. Voila. Isn't she amazing? So, we can just up that by about 50. Give that a... Cool. It's like a London Underground sign. So we can now color that in with a different color. And the fun thing is we can also do like a bordered color as well, which shouldn't be too hard. So should we quickly like see what we can do? Get that in. So we want to color op. So color solid. So where's that pink? Sweet. We want to chuck that on there. Then in the shader, they're actually below the shape, aren't they, these colors? Color solid. So you're grabbing an op, or a word, sorry. See, color's not a really good thing because it shadows this bugger up here. That could be called final color. Final color is probably a better thing to do. Alright, good. So we can call this color now. We then want to say like unpack this one. So you turn it from a U32 of 4 8-bit integers into a vector 4 color, right? And then that gets multiplied onto source color, and then you up that word index by 1. Cool. So try that. Should be pink now or something. What's going on here? Oh my days. This ain't no CPP. Let's do a temp thing. Source color equal mul source color, something like that. What's that? Oh yeah. Final color, please. And voila. Pink. Oh yeah. Oh, I'm not decrementing it. Oh no, that was earlier, wasn't it? Yeah, I fixed it. It's good. That's good. That's good. Thank you. Right. So we've got some solid color now. Should we do the border one for a bit of fun? This is part of the reason why we've done it, is so we can do this SDF lovely stuff. So imagine now if you like did that sort of bordered one. So you go from like a pink inner, and maybe let's do like an ugly green out, you know, Incredible Hulk style. Like this one, and you want to have a distance of like 16. Well, I don't know. I'm using a 4K screen now, so it's at 32 pixels. Cyan. What's the cyan? That'd be even worse. Have you got the hex code for cyan? But yeah, no, it's just easier because the green's here. Border. So it's got like 3 operands, hasn't it? I want to just order that quickly like that. So you have like an inner color. Yeah, so the most ugliest color you can make is literally like pure blue, you know. It's like real bad. I do like a cyan though. Well, I think one of my favorite colors is teal, you know. It's like a kind of like cyan. Maybe not exactly cyan though. Border color, and then you want to do a F32 of border width. Right, so how are you going to do this? Right, so you've got yourself a distance. Wait, so you should only be able to do this if the distance is 1. Yep, good. So we've ensured that the distance is 1, meaning you can actually grab the distance here from the distance stack bomb. And the source color is basically like, so you could lerp it, maybe. So it'd be a negative, right? So if you take that distance and negative that, so that'll make it obviously positive number now. And you basically just want to say lerp F32 times 4. See, we should really like unpack these. Let's unpack these buggers, unpack these buggers. Cool. So you want to lerp, so your source color, I think let's sort the T first. So you got your distance, so How close is that to border width? Is that all right? And anything? No, it shouldn't be a lerp. It's a clear cutoff, isn't it? It's not a lerp. It's a clear, like, yeah, it's a clear, like, if you're in that border width or not. So it's literally just like border width, question mark, wait, less than, if distance less than border width. Distance from the edge less than border width. We use the border color. Else we use the inner color. Try that out. Sorry, I put a comma in there like a pleb. Right, that looks sensible. But nothing. Why is this? Order solid. Oh, we did solid. No, I don't think it's wrong. Because we've asserted. So if you use color. Yeah, I think that's the problem. So if you use color. Yeah, when you use these color guys, it calls color assert. And what color assert says is that the distance operand index has to be 1. Meaning there's only one distance in the distance operand, so we can just index 0. Right? Basically. Yeah. Just got the green. But it's an improvement. What did we do again? I don't know what we did. Oh, we took out the solid. Right. So, something... Oh yeah, we didn't do negative distance. Damn you. Oh yeah. Did we get that right? I think so. But yeah, we just need to do the anti-aliasing still. But yeah, we can do all these beautiful shapes. So you can't union a red circle with a yellow ABB. Yes, you can't union them, but the way you do that is you just do 2 separate draws. Right? Because if they're just overlapping, then there's no point doing any of this union stuff. The whole point of the union is to make custom shapes. But you could... there's also... so the thing is, you can also do like smooth blends as well. Right? So if you had 2 circles of different colors and you did a soft blend, you can do that with SDFs. We could maybe interpolate the colors as well, which could be interesting, but then it'll be more compute heavy, that's for sure. I don't know how much though. We might have to have like a color stack alongside the distance stack, so every shape gets a color. But then how would the texturing work? Because how the texture works at the moment is like it'll take the whole thing, and this is like a mask in a way, right? And it sort of just uses... There's a box around it here. We've still got to work that one out. But yeah, you would... so as an example, there's like a soft... Yeah, or a smooth union, which is like proper sweet, right? So here's the standard union where it's just a clear cutout, whereas it goes soft, right? Cut out and then soft. So it's like it's pretty nice, right? We could do that with colors. So you could be like, oh, this one's red, this one's blue, and then it sort of interpolates that. It's possible. But I don't know how that will fit in though, that's for sure. Um, but yeah, this is pretty decent. So the others then, I don't know. Yeah, so we've still got to do texturing. That's gonna, I think that probably be the hardest thing to figure out, I think. But these other ones like intersection, rounded, expand, and outline are gonna be proper easy. Um, but yeah, so we're getting pretty close now. And then we should really add soft union and soft subtraction. And all of that sort of stuff. And maybe we'll think about doing the separate color thing because it does sound like an interesting thing. Like I can imagine like that being like a good use case, but if it's not easy to do and it messes up the texturing or something, I think we'll skip it. But it does seem like it seems like it'd be a good idea. Because yeah, as I was saying earlier, the other thing I'm imagining is like we can just literally have a quick and dirty UI thing to like basically build this. So you can be like, oh yeah, I want to add a circle, put the circle on, add a rectangle, put the rectangle on, and then we can like, you can reorder the commands and then it will just output the C code. And we'll just copy paste the C code, put it in the game, and there's your custom thing you've made, like the button. And I even imagine it as well where like perhaps you can have like, I don't know how much harder it would be though to have maybe do animation in it as well. Like maybe you could have a couple of inputs. Where you could say I've got a float input and I can just change it with like a bar and you can, I don't know how, that's probably a lot of work, but yeah, just something to think about and how useful any of it would be. Because really having like an interactive version, we can like build little custom like UI sort of with these primitives is proper powerful. Just wonder I wonder if you can do it in a very simple manner. But yeah, I'm super happy with the change we made today though. We did lose, in a sense, take a step back and went to the side, but it's a good sidestep. Right. So I think on the next stream we're gonna basically finish up all these draw things, different draw types, and polish it all off basically. See how far we get. I'm hoping to be finished with the rendering very soon. Yeah. Polish it off, and then the stream after we can do the optimization where we fill the screen with just tons of drawing and just see how well it performs. And see how well we can make it perform. Because ideally we want to give a lot to the game. And you know, I've got like 120, well, I've got 165 hertz display. So it'd be good if we could make something that could hit that. Have a mode that can hit that 120 hertz or some 65 hertz, you know. Yeah, pretty cool. Right, let's find someone to raid. Hope everyone had a good time. And hope everyone has a good start to your weekend. I am available Sunday and I'll be streaming from 4 p.m. GMT +1. And I'm just going to send you over to Nico, who's a FreeBSD guy. I'm not sure what we're streaming today. Yeah, always in some awesome stuff, Nico. So, yeah, thanks for coming, everyone. Have a good weekend, and I'll see you all in a future one. Thank you so much. Bye bye.